In this lecture, we will discuss the core interfaces of collection framework. Mainly, there are 7 interfaces as shown here. Collection interface, list interface, set interface, sorted set interface, navigable set interface, queue interface, and dequeue interface. As I said earlier, Java collection classes such as array list, linked list, queues, stack, hash sets, tree sets, and so on implements these interfaces. These interfaces has abstract methods or methods which does not have implementations but only definitions and allows its implementing classes to provide its own implementation. And these classes must provide implementation for all non-default methods. In this lecture, let's get familiarized with these interfaces and the methods which are provided by them. We will not discuss in detail about these methods for now, but we will discuss them in detail when we discussing about collection classes. Among the 7 interfaces, let's discuss about collection interface. The collection interface is the foundation upon which the collection framework is built because it must be implemented by any class that defines a collection. The collection interface declares the core methods that all collections will have. These methods are shown here. Familiarity with these methods is necessary for a clear understanding of the framework. Let's inspect some of these methods. Objects are added to a collection by calling add method. Notice that add method takes an argument of type E, which means that objects added to the collection must be compatible with the type of data expected by the collection. You can add the entire contents of one collection to another by calling add all method. You can remove an object using remove method. To remove group of objects, call remove all method. You can remove all elements except those of a specified group by calling return all method. To remove an element only if it specifies some condition, you can use remove if method. To empty a collection, call clear method. You can determine whether a collection contains a specific object by calling contains method. To determine whether one collection contains all the members of another, call contains all method. You can determine when a collection is empty by calling isEmpty method. The number of elements currently held in a collection can be determined by calling size method. The 2 array methods return an array that contains the elements stored in the collection. The first returns an array of objects. The second returns an array of elements that have the same type as the array specified as parameter. Normally, the second form is more convenient because it returns the desired array type. These methods are important than it might at first seem. Often, processing the contents of a collection by using array-like syntax is advantageous. By providing a pathway between collection and arrays, you can have the best of both worlds. I request you to go through all these methods at once. Do not worry, we will discuss them in detail when we are discussing about collection classes. Now let's move to list interface. The list interface extends collection and declares the behavior of a collection that stores a sequence of elements. Elements can be inserted or accessed by their position in the list using a zero-based index. A list may contain duplicate elements, and list is a generic interface such as it can work with all the data types. These are the methods available for list. Along with these methods, list inherits methods from collection interface, such as the methods that we have just discussed earlier is available for list interface as well. The methods add and add all can be used to add elements to the list at the specified index. To obtain the object stored at a specific position, call get method with the index of the object. To assign a value to an element in the list, call set method by specifying index of the object to be changed. To find an index of an object, use index of method or last index of method. You can obtain a sublist of a list by calling sublist method, specifying the beginning and ending indexes of the sublist. As you can imagine, sublist method makes list processing quite convenient. One way to sort a list is with the sort method defined by list. Beginning with JTK 9, list includes the off factory method, which has a number of overloads. Each version returns an unmodifiable value-based collection that is comprised of the arguments that is passed. The primary purpose of off method is to provide a convenient, efficient way to create a small list collection. There are 12 overloads of off method available. We will discuss about all these methods when we are discussing about collection classes. Now let's go to set interface. The set interface defines a set. It extends collection and specifies the behavior of a collection that does not allow duplicates. Therefore, the add method returns false if an attempt is made to add duplicate element to a set. Set does not specify additional methods of its own except factory method of. The primary purpose of off method is to provide a convenient, efficient way to create a small set collection. There are 12 overloads of off factory method. One takes no arguments and creates an empty set. 10 overloads take from 1 to 10 arguments, and final overload specifies a variable length argument parameter that takes arbitrary number of elements or an array of elements. Here you see only off method. All other methods are inherited from collection interface. Now let's discuss about sorted set interface. The sorted set interface extends set interface and declares the behavior of a set sorted in ascending order. Sorted set inherits method of set interface, which inherits methods of collection interface. Along with these methods, sorted set defines several methods that make set processing more convenient. To obtain the first object in the set, call first method. To get the last element, use last method. You can obtain a subset of a sorted set by calling subset method by specifying the first and last object in the set. If you need the subset that starts with the first element in the set, use head set method. If you want the subset that ends the set, use tail set method. These are the methods defined by sorted set. Now let's discuss about navigable set interface. Navigable set extends sorted set and declares the behavior of a collection that supports the retrieval of elements based on the closest match to a given value or values. In addition to the methods that it inherits from the sorted set, navigable set adds these methods shown here: ceiling, descending iterator, descending set, floor, head set, tail set, higher, lower, pole first, pole last, subset are these methods. Now let's discuss about queue interface. The queue interface extends collection interface and declares the behavior of a queue, which is often first in first out list. However, there are types of queues in which the ordering of elements is based upon other criteria. Queue offers several points of interest. First, the elements can only be removed from the head of the queue. Second, there are two methods that obtain and remove elements: poll method and remove method. The difference between them is that poll method returns null if the queue is empty, but remove method throws an exception. Third, there are two methods, element method and peak method, that obtain but don't remove the element at the head of the queue. They differ only in that element method throws an exception if the queue is empty, but peak method returns null if the queue is empty. Finally, notice that offer method, which only attempts to add an element to the queue. Because some queues have a fixed length and might be full, offer can fail. It does not throw an exception, but returns false if fails to add an element. Now let's have a look at the final and seventh interface of this lecture. DQ interface extends queue interface and declares the behavior of a double-ended queue. Double-ended queue can function as first in first out queue or last in first out stack. Notice that DQ includes methods push and pop. This method enables a DQ to function as a stack. Also notice the descending iterator method. It returns an iterator that returns elements in reverse order. In other words, it returns an iterator that moves from the end of the collection to the start. And DQ implementation can be capacity restricted, which means that only a limited number of elements can be added to the DQ. When this is the case, an attempt to add an element to the DQ can fail. DQ allows you to handle such a failure in two ways. First, methods such as add first and add last throw an illegal state exception if a capacity restricted queue is full. Second, methods such as offer first and offer last returns false if the element cannot be added. In addition to these, DQ also provides remove first occurrence, remove last occurrence, and remove last methods. Now we know about core interfaces of collection framework. Collections also use comparator, random access, iterator, list iterator, and split iterator interfaces. Comparator defines how two objects are compared. iterator, list iterator, and split iterator enumerate the objects within a collection. By implementing random access, a list indicates that it supports efficient random access to its elements. In the next section, we will discuss about classes which implements these interfaces.